The farthest human target on Earth was the NASA Voyager 1 spacecraft and into the interstellar space. Imagine 45 years ago, start the spaceship and go beyond the limitations of charges, challenge expectations and experience the planned mission. This changes our understanding of space research with the amazing reality of the NASA Revolution mission. But even more noteworthy is that this stable spacecraft, which currently reaches billions of miles, still transmits data to Earth using older technology than cassette players. Voyager 1, which began in 1977, just discovered that it stunned the scientific community and attracted global attention. What is this amazing thing in this amazing space, and what does it mean to us on Earth? When the two most amazing space missions began when they were released in the Cosmos Research era, history had a key point in history. Thanks to the excellent heart of the NASA Reaction Laboratory, for the probe, it was applied to the perfect route will to reach the distant planetary Jupiter, Saturn, Chiron Royal, and Neutral. In the late 1970s and early 1980s, Flandreau made only pencils and engineering tools in the 20th century, and in the late 1970s and early 1980s, for gas giants will be aligned in a unique space composition to create a heavenly necklace with Earth. With this leveling, spaceships can speed up using the planet's gravity, which is very similar to the fact that the invisible rope pulls it. Through these gravitational programs, travel to Nirwangsiang, which usually occupied 30 years on Earth, may have been completed in just 12 years. But the needed equalization of the Earth occurred only once every 176. By taking advantage of this rare opportunity, NASA moved quickly by launching two same spaceships, Voyager 1 and Voyager 2, to benefit from the Sky event in the summer of 1977. You never know that researchers have won all notes in the history of space mission. 45 years after Voyager 1 and Voyager 2 were released, we still work to send information about the edge of the solar system every day. This probe has become the farthest spaceship in history and has surpassed the first imagination of the first imagination, given that the initial mission has been planned for 4 years. At the beginning of the epic journey, they revealed the world by providing amazing images of Jupiter and Saturn's lunes, and much more active and dynamic than expected. The discovery of active volcanoes and ice fields has ever changed the understanding of the solar system's remote corner. In particular, Voyager 2 was changed to Changwangxiang in 1986 and became the first spaceship to visit the planet in Neptune in 1989, and to visit the amazing scientists with amazing discoveries in the previously unproven territory. At the distance of more than 14 billion kilometers on the ground, the probes each surpassed the boundaries of our understanding, each with the size of the Volkswagen Beetle. The Voyager mission began with gravity flight, and on the way to Mercury, unprecedented maneuvering on the spaceship to strengthen the state of the true pioneer. The trip to Jupiter lasted 10 times the distance between Earth and Mercury, and required to explore the dangerous belts of asteroids performed by the Pioneers 10 and 11. But obstacles did not stop there. A total of 69 kilometers of memory, which is part of the latest smartphone's ability, must rely on their intelligence to manage this special journey. The data collected by Voyager tools were stored in the magnetic records of 8 tracks and then transmitted to Earth through the transmitter and used only 20 to 23 watts. The same power as a light bulb. The spacecraft is equipped with a 12-foot satellite plate to facilitate communication. They used light wireless waves to send and receive messages and increase the distance on the ground, and they moved to 3 to 4 seconds every day to suggest serious problems. Despite this problem, Voyager probe exceeded expectations and amazing astronomers with amazing discoveries in the depth of interstellar space. Their journey was changed by our understanding of the universe and changed unknown perception. Outside of our solar system, there is a mysterious cloud of the Oort. While travelers continued to get a gradual approach to this distant area, the passage to the interstellar space began when separating our solar system from a wide range of space. Initially, the border was estimated at about 50 astronomy units, AU, on Earth, so the investigation decided to continue to raise the mission even if the investigation approached this milestone. However, the intersection of this border was confused by scientists because it could not immediately find a change in the environment. The passage of the interstellar space was expected to increase rapidly the number of high-energy particles that moved at the speed of light, which was driven by supernova and other universe phenomena. Most of this high-energy beam is reflected as a magnetic shield created by heliosphere, which protects the solar system from most external threats. When the buoy was filled with an ionized gas and went to the interstellar media in the area formed by a nearby star, the mission team carefully monitored the shift of the surrounding magnetic field. Scientists predicted that the intermagnetic field would be oriented differently from heliosphere. Nevertheless, Voyager studies have not found significant changes. On August 25, 2012, Voyager 1 finally crossed Heliopause to confirm the expected growth of plasma density, but sent interesting data that did not show evidence of the change of magnetic field. The researchers were unexpectedly predicted that the transition from the Sun magnetic field where other stars influenced it. The results have caused a strong debate in the scientific community. If the magnetic field has not changed significantly after the intersection of Heliopause, what about the interstellation environment and how the photovoltaic system interacts with the environment? Voyager 1 provided a window in an area where it was not related to this new area, known as an adult space, but raised more questions than the answer. An early theory suggested that the interstellar magnetic field could unexpectedly be aligned with the solar heat, which could cause a soft transition, not a sharp cut. This will mean that the forces that form the space Earth are more complicated than we imagined. The data also showed a noticeable increase in high-energy particles of space beams due to the limitations of the solar system, and Voyager 1 officially left the protection bubble of the solar effects known as heliosphere. But if there is no noticeable change in the magnetic field, the mystery remained. Some scientists have suggested that the influence of the Sun can still have a broader transition area than the argued areas that still interact with interacted media. Others suggest that Heliopause is not clearly defined boundaries, but a fuzzy boundary that changes depending on factors such as sun cycles or pressure applied by interstellar media. Voyager 1 went beyond Heliopause, and the data he returned to the ground challenged for a long time. Observation of plasma density has found amazing changes, suggesting that interstellar space is not uniform emptiness after home. Instead of simply calm, this huge area consists of plasma pockets. Each shows its unique density, temperature, and energy level. This discovery embarrassed scientists because the existing model predicted a relatively uniform interstellar media formed for thousands of years due to the stable influence of star winds and space radiation. But Voyager 1 heard different stories. In just a week's observation, the probe recorded a fluctuation of plasma density, indicating that it was unexpectedly poor and cold, crossing the area with different characteristics of dense and hot. The contrast began to describe this area as plasma clouds. Further analysis shows that this cloud is a remnant of ancient supernova, depending on the visible, and that the interstellation environment can still be evaluated for the deadly star explosion that is still millions of years ago. Each of these pockets can serve as a relic and provide ideas for the turbulence of our galaxy.